Hello, in this video we're going to have a look at a couple of examples of how to work out the equation of a line given a couple of points on that straight line. Just a real quick revisit of the key ideas from last lesson. First of all, there's a straight line. Remember, it's different from a line segment that instead of having a definite start and a definite end, it goes on forever in each direction. In fact, it would have been probably a little bit better if I'd put arrows on the end. You don't have to, as long as the straight line does sort of imply that it goes on forever without a definite start and a definite end. That's okay. So given this, we talked about there being two or three key properties really. One is the x-intercept, which is where the line passes through the x-axis. The second is the y-intercept, which is where the line passes through the y-axis. And then we talked about there being something called the gradient, which is how steep this line is and in what direction that line is going from left to right, up or down. So a gradient is either positive if it's going left to right, upways, or it's negative if it's going left to right, downways. And the higher the number is, the steeper the gradient is. Okay, this is the gradient formula that we looked at yesterday or last lesson. Y2 minus y1, that's the difference in y coordinates for the two coordinates that you have, divided by x2 minus x1, which is the difference in the x coordinates, with the idea that this is the rise, the change in y, over the run, the change in x. Okay, so bringing these ideas together, we have this form of an equation which represents, or a rule that represents this straight line. It's y equals mx plus c. So m being the gradient and c being the y-intercept. And we discussed why this works last lesson, so I'm not going to go through it today. Instead, I'm going to go through a few key examples and then I'll let you do some practice work. So here's example one. We have a straight line that's passing through the x-axis at -2, so that's the x-intercept, and it's passing through at -4. We can see that this straight line is going downways, and so we would expect the gradient to be negative. So to come up with the equation here, we are going to need to work out the gradient first. So I'm going to start by going m is equal to y2 minus y1. So we need to work out the y coordinate here and the y coordinate here. Now the y coordinate here is 0. Why? Because this means -2 x coordinate, 0 for the y coordinate. So it will be 0 minus, and then this as a coordinate is 0 minus 4. Nothing in the x direction, but 4 down in the y direction, so 0 minus 4. So that becomes 0 minus -4 over -2 minus 0. Okay, working that through, subtracting a negative is the same as adding, so I've got 0 plus 4 over -2 minus 0. The top of it becomes 4, the bottom of it becomes -2, and 4 divided by -2 is equal to -2. So we've got y is equal to -2x plus c. Now, if you remember from our key ideas, c is just the y-intercept, and in this instance, we're given the y-intercept, it's -4. So we don't need to calculate anything, we can just directly substitute -4 for c. So we get y equals -2x minus 4. Why -4? Because it's a -4 here, and when you add a negative number, it's the same as subtracting. So the equation is y equals -2x minus 4. Example 2. In this instance, I've been given the y coordinate, the y intercept, and one other point. So I can immediately write this out as y is equal to mx minus 2 to start off with. So m is the only thing I need to figure out so that I can finish this off. Again, y minus 2? Well, because the y-intercept is -2. So the -2 would go here in place of plus c. Okay, let's work out the let's work out the gradient. I'll try and do this a little bit faster than I did last time. So it's y2 minus y1, so it's going to be 1 minus, and then the y-intercept here is -2, so it's going to be 1 minus -2, all over 6 minus, and then the y-intercept means that the x coordinate is 0 here, so it's 6 minus 0, which is equal to 1 minus -2, which is 3. 6 minus 0 is 6. And I'm just going to simplify that fraction to a half. Yes, it's okay to have a fraction as your gradient. So m is equal to a half, and I can write that now as y equals a half x plus, sorry, beg your pardon, half x minus 2, and that's the full equation. You may see the back of the textbook might write it as y equals x over 2 minus 2, and that would be fine as well, because a half x means a half times x, and a half times x is x divided by 2, or x on 2. Okay, one last example. Let's just say you're given a word equation instead of, a word kind of like the information without the graph. You can still do it, of course. Find the equation m equals a third, 0.3, 1. Okay, in order to solve this, you are simply going to write the equation out with the information that you've got. So it's y equals mx plus c. I've been given m, so I can write a third in. So it's a third x plus c. So hopefully you can see that the thing that's missing is c to complete the equation. So I need to work out the value of c. So what you do is you find the other point that you're given, in this case 3, 1, and substitute it in for x and y so that you can work out what c is. So remember, 3 is the x coordinate, 1 is the y coordinate. So I can take y equals a third x plus c, and I can replace, at 3, 1, I can replace y with 1, and I can replace x with 3. So that gives me 1 is equal to a third times 3, which is 1 plus c. And if I subtract 1 from both sides, I get c is equal to 0. I've just swapped sides here because we tend to be left to right readers. So I was left with c on this side, which I put there, and 0 on this side, which I put there. So c is equal to 0, and I can conclude, if you haven't seen these three triangles of dots before, that means therefore y is equal to a third x, and that's it, plus 0. So if I'd had a different problem, and I'd got a value for c that wasn't 0, let's just say I got c equals 2, then I would end with plus 2 here. And that would be my equation. But because I've got c equal to 0, then the whole thing here is just equal to 0. And that is basically it. That should be enough now for you to be able to complete a whole bunch of problems from your textbook. So please visit Google Classroom and make sure you have a look at what work you have to do there, and attempt as many problems as you can. Good luck.